Welcome to lecture Operators in Java. In this session, we'll explore operators, which are essential for performing calculations, making comparisons, and controlling program flow. Understanding how operators work will enable you to write more complex and efficient Java programs. Operators are special symbols used in Java for mathematical calculations, assignment operations, and logical comparisons. For instance, C3 plus 5 uses the plus operator, and 14 plus 5 minus 4 times, in parentheses, 5 minus 3. It uses addition, subtraction, and multiplication, and also it uses parentheses. Operators work within expressions. Expressions are combinations of variables, literals, and operators that produce a value. Java has 5 main types of operators: arithmetic, assignment, increment, decrement, relational, and conditional or logical operators. Java has 6 basic arithmetic operators: addition, subtraction, multiplication, division, and modulo. Java follows the PEMDAS order of operations: P for parentheses, E for exponents, MD, multiplication and division, AS, addition and subtraction. Operator precedence determines how expressions are evaluated. Consider 10 plus 15 divided by 5. Two possible ways to evaluate this. First, we add 10 plus 15, which is 25, and then divide by 5, which is 5. Or the other one is 10 plus 15 divided by 5. So 15 plus divided by 5 within parentheses will be equated first. That is 3. So 10 plus 3 is going to be 30. Since division has higher precedence than addition, Java follows the second approach. To avoid confusion, always use parentheses to make your calculations explicit. Integer division behaves differently from standard division. In the example, I is integer, which has the value of 63, and j is an integer also, which has the value of 35. So if we print I divided by j, the output will be 1. Even though mathematically 63 divided by 35 is approximately 1.8, Java truncates the decimal part when using integers, returning the value 1. However, using double values preserves precision. Okay, so if we declare x and y as double, the correct data 1.8 will be printed. So always choose the correct data or data type based on whether you need decimals. The assignment operator assigns a value to a variable. In the example, int x equals 10 assigns the value 10 to x. Java allows compound assignment operators to simplify expressions. For instance, x assigned x plus 5 can be written as x plus equals 5. Similarly, y equals y times 7 can be written as y times equals 7. These shorthand operators make code more concise and readable. The increment and decrement operators increase or decrease a variable by 1. Count equals count plus 1 can be rewritten as count plus plus or plus plus count. Similarly, count equals count minus 1 can be rewritten as count minus minus or minus minus count. Prefix operators or increment and or decrement operators such as plus plus count increments first, then evaluates. The postfix one evaluates first, then increments or decrements. Relational operators compare two values and return a boolean, which is true or false. In the example, x is 3, y is 5. So result is assigned the value of x greater than y. So since x is not greater than y, so result will have a value false. Comparison operators are essential for decision making in programs. Conditional operators are used to combine Boolean expressions. And, which is written with two ampersands, both conditions must be true for it to be true, and or at least one condition must be true to be true. Note simply inverse the existing value. If it is true, it becomes false. If it is false, it becomes true. In the example, x is true, y is false, and result is assigned the result of x and y. So since one of them is false, then result will have the value false. But in OR operation, since one of them is true, then the result will be true. These operators help control program flow by making decisions based on conditions. Java uses short circuit evaluation for both double ampersand and double pipe, and OR. In the example, A and B++ greater than 0. If A is false, Java skips evaluating B++ greater than 0, since false and anything is always false. This means B will not be incremented. Similarly, for x or y, if x is true, Java skips evaluating y, since true always becomes true if the first value is true. This optimization makes Java programs run faster. Java also supports bitwise operators, single ampersand and single pipe, for integer values. In the example, A is 1, B is 2. Result 1 equals A and B, and result 2, A or B, will give you an integer result. Bitwise operators work at the binary level, performing operations bit by bit. Both operands has to be of integer data types. Let's test our understanding with some quick questions. In the first question, the trick is 3 divided by 6, which will be 0, because both 3 and 6 are integers. So using PEMDAS, so first the multiplication will be done. 5 times 3 is 15, minus 3 divided by 6, 0, minus 9 times 3, 27. So the result will be minus 12.